Uh, Dear students, in this video we are going to proceed from the feedback that we have discussed in the last video. And we if I have to revise that in a very short way, if we rightly remember what we used to have an input signal of less amplitude. Then we subject this input signal to an amplifier, and we get an output, and the magnitude of the output is large, because the job of amplifier is to enhance the magnitude of the signal. And then we subject this signal back to the feedback circuit, and then we have a feedback circuit. And and if the result here is such that the wave that we obtain here is in same phase with this input signal, then we call it positive feedback. And if the output signal that we obtain here is out of phase with respect to this signal, then we call it as negative feedback to the amplifier. Now, the point is that we either have a signal with same phase, and if our feedback circuit is such that our output is out of phase with respect to this signal. In this case, we call it positive feedback, and in this case, we call it negative feedback. Now, this feedback circuit, it has a symbol associated to it, what we call as feedback ratio. Feedback ratio. And this feedback ratio can be represented by, say, for example, we take it as beta, and this beta has a relation with the output of the feedback circuit and to the input of the feedback circuit. So this is my beta. Now, if I go back to the original circuit, to the original diagram that I had shown you, it was like this. We have an amplifier, and it has input, okay, and output. Then we have feedback circuit, and then say this is, we have signal voltage here, Vs, and here we have VO, and there must be some gain in absence of the feedback, and that gain can be the ratio between the output signal and the output voltage and input voltage. Now, if I subject this to the feedback circuit, so here we have V out, and then we have beta here. Now this beta is feedback ratio. So here we have an output, and that output is VF. And certainly here the input for the feedback circuit is VO. So if we have to write this feedback ratio, it must be VF by V out. So VF must be beta times V out. So then what we do, we subject it back to the amplifier. Now, let us assume that we are talking about the feedback a positive feedback system. So in case of positive feedback system, we understand that we have an input signal, then we have amplified input signal, then we have amplified input signal, and then we have a modified signal here, whose who has the same phase as that of the V out, or it is in same phase with respect to the input voltage. Now here I told you in the previous video that the amplifier that we use here is a common base. Is in the common base configuration. So once it is in the common base configuration, the signal will come in the same phase, but the amplitude of the signal that will obtain at the output will be large. It will be more than that of the input voltage. Now, in order to proceed, if we look back here, if I have to write down some mathematical equation here, I can think of this feedback circuit, and I can say that this. If I think in terms of this looping, I will have some voltage here when things will come back to the input of the amplifier, and if I call that as Vi, this Vi must be equal to Vs plus Vf for positive feedback. So if this is the case, then we better know that this Vf can be written as we know that this Vf by V out is beta. It is the feedback ratio. So Vf can be written as beta V out. Now, this value can be used in this equation. Say, for example, this is 1 and this is 2. So what I'll get Vi is Vs plus beta V out. Now, to make more simplifications in this equation, because I want to calculate the gain, the overall gain, when we supply feedback to an amplifier. Amplifier has its own gain, so there is a gain in absence of feedback. There is a gain in presence of feedback. So what is the motivation here in this equation is that I want to find an expression for the for what's called as the gain of an amplifier in presence of positive feedback. So if I go with this equation, if I divide this equation by Vi, I'll get Vi by Vi, that is Vs by Vi plus beta V out by Vi. Now this certainly is 1, so this I can write as Vs by V out into V out by Vi plus beta V out by Vi. This is the gain of the amplifier in absence of feedback. So this V out by Vi, it is gain. It's the gain of amplifier in absence of feedback. I have a bad handwriting. So this gain we can represent it as A. V out by Vi, I can show it as A. So here I'm using A. Now let's proceed. So what can we see here? We can see here that this Vs by V out, and then we have V out by Vi. right? Now this V out by Vi, it's understood it is A. So I can use one one equals Vs upon V out A plus beta A. Now let's proceed from here. So now now what is left is one is Vs upon V out. Then we have A plus beta A. Now, what is Vs by V out? Vs by V out is it is basically the gain in presence of the feedback. So here we have the reciprocal of V out and Vs. So this Vs by V out, let me represent it as, say, for example, A dash. So it cannot be A dash, it has to be 1 by A dash, because originally A dash must be V out by Vs. Okay, so V out by Vs, this must be the gain of gain in presence of the feedback circuit that we have attached to the amplifier. Now if this is the case, then here I have to use 1 by A dash. So 1 must be equal to A by A dash plus beta A, right? So I can write A by A dash is 1 minus beta A. Okay, so I can take the reciprocal. A dash by A is 1 by 1 minus beta A. So my A dash will be A divided by 1 minus beta A. So this equation is going to give me the gain of the amplifier in the presence of the positive feedback. So this equation is valid for positive feedback. And we can mutually understand that if we do the same analysis for the circuit in which we are making use of negative feedback, certainly in evaluating these equations, we will finally find the equation for the gain in presence of negative feedback that must be equal to A by 1 plus A beta. So here we have evaluated two equations. We have evaluated the gain of an amplifier, the positive gain of an amplifier when we are making use of positive feedback to the system, and when we make use of negative feedback, which I have already explained, in that case the gain comes out to be A by 1 plus A beta. One thing should be kept in mind: this A belongs to the gain of the amplifier in absence of feedback, whether we have negative feedback or positive feedback. And this beta, this beta is the feedback ratio. So here I would like to end this video, and then let us see what will be the next.